All right, we have 10 students now. Before we start the class, let's give a round of applause to the students who shared last week. Why are we applauding? Because last week I mentioned there are 3 types of tasks you can try. The first type is using what we've learned in previous units to modify some files yourself, then directly read the data you found using the file method, or create some fake data in your code, or find real data online and paste it into your program. The third type is finding some public APIs and connecting them with your program to make dynamic inputs of real data. Now we see the student Chen Hui Mei from Sharon High School who was able to find an external API to get real data. So why did I design these 3 different levels of tasks? Because I'm sure there are experts among the online students here. Let's take a look at how it was done. If you also want to learn how to obtain some investment data like him, you can refer to his method. You'll see that in this section, he downloaded a Chinese font to display Chinese text in the title, X label and Y label. To check the Bitcoin price, he first got the Yahoo Finance API. This Yahoo Finance API is very easy to use because it's free and fully integrated with Python. You just need to input the Finance API package and you can directly use the Swift object. This Swift object, let's look at it, directly downloads the product name. The product name is BTCUSD. You might wonder how you know what the product name is. You just go to Yahoo Finance. When you get to Yahoo Finance, you'll naturally find this code. You'll see that it has this code here. This code you'll find is actually on the website. That's how you know you can find it here. We can switch it up too. Suppose we switch to Google, which is the company Alphabet. Its code switches to Goog. So if you're eager to try, you can paste Goog in place of BTCUSD, and you'll find the data you get will be different product data. Here it says he wants 1 month and daily prices, so he can get 1 month of daily prices. This means I can get this 1 month's data, and I'm looking at daily prices. So if you want to see the 5-day average price or the price for a month or 6 months, you can switch and check it here yourself. Now, when you're switching, if you're not sure about the period, whether to take a year or 3 months or half a year, and how to write the code for it, you can just ask directly. You can directly ask, I want this. Sorry, not this. I want to restore. I want to open this chat window. Let me find where the chat window went. Oh, here it is. Okay. Here, you can tell him you want to ask this Not this. I want to ask the chat window. Oh. Here. Okay. This is the right one. I want to ask this chat window, and then I want to tell him if I want to change it to fetch data for a year, how should I set my theory? Now, for a year, you can also specify which year you want. So at this point, he says change it to 1 year, then asks, do you want to fetch a specific year? Because what he means by a year should be calculated as 1 year back from today. So at this point, he will say you can set the start date, end at the start date, so he can directly modify it here. After you can modify these, you can extract this data, and once extracted, you can apply the line chart methods we taught before to draw it. So this student's code we will continue to use today to teach everyone how to establish a price comparison between two different products. Okay, besides this student, there's actually another student from Shalom High School. So Chen Huimei and Peng Yuyan, these should be names chosen by students, the same as the movie star Peng Yuyan from our era. Not sure if it's a real name or a tribute to Peng Yuyan, but it's quite interesting. He also did this BTC. He should also be doing. He didn't manage to show this successfully. Okay, that's fine because there's a successful one. So in a moment, everyone can look at Chen Huimei's version. Another one is from Keelung High School. He took the weather. Let's see how he got the weather. So here he said he got the weather API. Let's take a look at this URL. Check where this URL comes from. So this URL is here. Do you see it? Latitude and longitude. Then there's degrees Celsius here. So here the latitude and longitude have degrees Celsius. So he successfully got this API. So he got this API. If you're curious, you can also ask, just ask him. So why do we encourage everyone to share like this? Through sharing, you can actually learn more. Moreover, if you can use AI to help you analyze the code during the sharing process, you learn some clever ideas discovered by others. Then you can directly apply them. Okay, so he said this is the Redux link. But if you still don't know what it is, you can ask him which unit provides it. Okay, if you're really curious, because he said this is Open Metal API, and it might be an open source service that specializes in providing climate data. So I think he's great because he found this open climate data. You can also ask him if there are other APIs like this. I want to set up a certain program. For example, he directly inserted the latitude and longitude at the end and then retrieved it. If we want to set up a certain program, he said you can actually use this open weather. It's not necessarily the API that this student got, which I haven't used either. It's Open Meteor. You can compare the API he got with the open weather he recommended. and the usage will be slightly different. So at this point, he teaches you how to obtain it. Well, these two students did something very special, so I'm taking this time to talk about it with everyone. Next, we're going to teach data comparison. Let's open it up and directly use Copy to Drive. After copy draft, you'll see that I also used a random method here to generate two data sets randomly. Do you see it? This is randomly generated. Last week, we also taught random. After generating randomly, I let it draw a line chart. But drawing it like this is actually quite boring. So how do we use this student's method to compare the changes in two stock prices and the climate changes in two cities? Let's give it a try. So here, if I want to refer to what this student did, I'll just copy it over. Then he wants to do this in Chinese here. I don't want to do it now, so I'll stick with English. But if you want to do it in Chinese, you can copy his font over to use. Then I can tell him I want to take this date and get copy this segment, copy and paste it here. I want to compare from January of 2005 to April 15th of 2006. Let's compare up to yesterday, the day before yesterday, Wednesday. I want to get the daily data. This is the data and maybe some BTC. I want to look at one more thing. We can look at the Google we just mentioned and change this to Google. And we want to compare the same period to see if you had put the same amount of money in Google or bought Bitcoin, how much would you have now? That is when you entered the market, you left it alone, and now see if you made money or lost money. Then let's read it, and after reading, we can print it out, okay? It printed out this much. Okay, we can check it again. Then check here because I believe everyone wants to make money. So using the stock prices and Bitcoin prices to spark interest in data reading might be more interesting. Okay, at this point we need to do something. We need to swap out what we just read. So I decided to throw this up and throw this data up. Throw it up, throw the data up, and after throwing the data up, I make sure all the data is up there. Then I can start modifying my code. I started to change this random, so I don't need it anymore. What do I need to take here? I need to take this date. I want to take this date for the horizontal axis. So its date is because it belongs to pandas, right? Its date is vertical, and behind it are open, high, low, close, right? So we can know that if I want to take the date, I can try to see if it works. Take the date out. Oh, it doesn't work. So the date can't be taken out like this. Did we guess wrong? What should we do? It's okay. We can tell it that if I want to take out that date column, how should I do it? It tells us that actually If you want to take it, you can use the data frames index to take it out, and then once accepted, you'll know. Let's take a look at the date. So we can take this date out. Okay, so this horizontal axis is no longer the week, right? It should become the date. Then what about the vertical axis? The vertical axis will be all the data, right? If it's all the data, it has 4 columns because it has open, high, close. Let's assume we use close for all of them. Okay, we guessed wrong again. What should we do? It's okay. You don't need to memorize it. Your logic is correct, but you're not very familiar with the syntax. You can learn through this. It means you want to take the close price. Let's take a look at the price close. Let's try it. After we change it like this, okay, so it means he misunderstood too, right? We've decided to print out all the names so we won't have columns issues. We print out all the names. Okay, so actually you need to do columns like this. Inside this price, we need to tell it that it's a multi-index. We need to tell it like this, then how do we take it out? Okay, at this point, it actually guessed what we want, but we still want to ask it to give it to us. So it means that it's like this, no mistake. Let's try it. Why can't we take it out? Okay, we accept it. Let me see where it put it for me. Oh, okay, it already put it here for me. Then I just checked, did we write something wrong just now? So we need to try again here to see if we can successfully take it out. Okay. Here, then we need to tell it. But you can take it out here, so why can't we take it out here? Okay, then, here. If it can be taken out, it must match completely here. So it means that what it gave us is wrong. It should be price close, but what it just gave us was close Google. It's a naming issue. Okay, then we accept it. Okay, take it out. Make sure it's taken out. So at this point, I can turn it into data 1. This is data 2. Okay, run it again. Okay, because it generated it for me. I think it's better if we do it ourselves. So I put it up. So here it's taken, and then this data too is also confirmed to be taken. I need to put it back because we just deleted that modified piece of code. So let's restore it, undo, undo. Oh, because I used delete, it's already been removed. No worries, I can open my original because I just copied it to Drive. So this part can be easily copied back, copy, copy cell. All right, let's organize it again. Get the data, then get the data, get the data. So when I want to draw in this chart, I don't want this random. I just deleted it. And for this week's, we did an action earlier, which was to take the index as suggested. You can take the index here. All right, here it might be data 1, and this is the index. So you can put it here, and if it's the same data 2 and also index, then you can place it here, and then comes our price. So the price was successful earlier. So this part I know. All right, place it here, then data 1 equals. So this way, data 1 can be placed here and data 2 can be placed here. All right, then here, what will the label be? The label is it, right? Because you want everyone to know how it is displayed. Google is it, right? All right, then here, compare to price. Oh, Christ. Then this becomes date. Okay, we can run it and see, all right, it's drawn. Now, why is it sticking together like this? The reason is simple, because its value rate is different. Google always stays below 10,000, right? But Bitcoin has surged past $100,000 before. So if the value rate is different, what we actually want to see is the return. This way we can put it in the same domain. So at this point we can be lazy and do one thing. Because at this point it has become an action called feature engineering. I want these two sets of data to fall within the same domain. So I want to become daily return. This way, daily return means I only look at the difference in rise and fall compared to the previous day. Isn't this always in percentage? So at this point, how do you become daily return? It will be red here. Then it can directly become a return writing method. And here it will be added for us. Let's take a look. Once added, it becomes like this. All right, accept. Okay, once added, you'll notice that if Google goes in and out every day, this is its return. It stays more in the middle. However, if you buy BTC and go in and out, then when you're in the middle, there's a chance of sudden big drops or rises. All right, if you can continue to change, how do we adjust? Here it can help you tell a story. So we can tell the story here, saying that because BTC is very volatile, frequent in and out can lead to big rises and falls. Then you can continue to ask, if I deposit the same on January 1st, 2051, deposit each one. $10 to 2 products. I want to see 206, and we just said when we sell on what date, right? Here, selling on April 15th, how do we calculate this cumulative return? This way you'll know, because if you only look at the price, the quality difference between the two is significant and you can't see the subtle changes. So we will convert to the same quality. So converting to the same quality, right? This kind of daily return percentage is one way to express it. Another way is to invest the same amount of money, and then the same amount of money will convert to different units. And when the holding time is the same, we look at what the final output price looks like. Okay, let's execute it and see. Okay, and it was wrong here, right? So we can flip these two over here because it initially gives an error, which we've already tried. So you can't completely trust what AI gives you because it might be wrong. So you need to know how to correct it and understand where it went wrong, then adjust it. Okay, execute it well. So at this time, it will look different. Look, suppose if you put $100 in January 2005 and don't touch it, you just follow the price changes like this. If you sell now, you can earn nearly 180 on Google. But if you put $10 into Bitcoin in January 20, you only have $80 left now. So this is an interesting comparison, isn't it? Compared to when we only looked at the original price and not at daily return or using this kind of benchmark where $10 is the entry point, you will know this process is called feature engineering. Because if you use the original data for processing, you will find that sometimes the original data may not be smoothly interpreted. So this is a very good example for everyone to refer to. Now, with this example, you can directly take out this piece of data. Okay, how do you take it out? You will see it here. What is he holding? What is he using to draw? So what he's using to draw is what he's using to interpret, right? So we can take a look at this explanation of the automatically generated conclusion. How do we look at it? If we look at it this way, he got this segment, and after getting this segment, you will know that this difference is 8 to 8. This is what we set ourselves. So if we can set 8 to 8, the relationship between them. So can you say if this daily return is greater than 5 or less than 5? This is also a way to say it. It could also be said that our investment return increased by $20 or $30 or $40, which is one way to say it. Okay, then we can look at this whole segment. If we look at it as Bitcoin, we change this source. Okay, suppose this source becomes like this, and then we subtract the beginning from the end, and if the difference is greater than $20, okay, then the story here would be that the overall price has significantly increased and the investment strategy might be effective, right? And if it's less than 20, the overall return rate, okay, it should be the return rate, not the price, might need to adjust the investment target, something like that. You see? So if this is the case, overall changes are unlikely and may require long-term observation or the addition of new investment tools to see. Okay? So you see, because we just saw $10 go in and now only $80 come out, so of course it becomes 20 here. So the overall return decreases and the investment targets need to be adjusted. So we use a simple method to extract the data, and you'll find that the entire code will undergo a major change. With the same logic and foundation, you can achieve different applications and different results. Okay, I'll share this now. Once I share it, what should everyone do in the next class? Can you try using public data to extract and compare two sets of data? Thank you very much. Also, thanks to the teachers for their suggestions. There's a Taipei City dashboard here with a lot of public data. Everyone is welcome to come here and take a look. Then you can take it back and use it directly. Okay, I'll share PQ's presentation from April 17th here. Okay, I'll share it. You can take a look in a moment. This is my simplest version. This is the simplest version using fake random data. If I connect it with more complex public data, the entire code will become longer, but the logic remains exactly the same. The final step of integrating with Plotly is also exactly the same. Don't be intimidated by the longer code. As long as you can start by replacing simple fake data and static data with meaningful data from real online sources, your skills will gradually improve. Okay, now I'll hand the time back to everyone. I encourage you all. I've seen your sharing. So your sharing is very important. You see, through the previous sharing by classmates, all the students today will be able to perform this financial data extraction. Now I'll hand the remaining time back to everyone. Thank you all.